Okay, so the first thing we need to do is find a common ratio. So from 1 to 3 to 9 to 27, we've already done this. What was the number that we multiplied by? Well, we multiplied by 3, and so 27 times 3 will give us the next term, which is 81. Okay, so here we talked about this one as well. The common ratio, the number that we multiplied by, was 1/2. So if I multiply 10 by 1/2, I'm going to get 5. That's the next term. So here I had that 3, 6, 12, and 24. Remember, I'm multiplying it by 2 each time. So the next term is going to be 48. Okay, so the question that we have now is, how do we find the next term? How do we find the common ratio? Well, steps are right here. To find the common ratio, you divide the term in the sequence by its preceding term. So you have to kind of go backwards like we did with the difference. So we have a 108 divided by 120 or 324. So if we have our calculator here, we do 108 divided by 324. And if I do that, I get 1/3. And then if I do 36 divided by 108, I also get 1/3. Okay, so see on my calculator I got 1/3 both times. So the common ratio here is 1/3. So I'm going to take that 36 now, 36, and I'm going to multiply it by 1/3 to find the next term. Well, in this case, it's 12. Okay, then I'm going to take that 12 and I'm going to multiply it by, again, 1/3, and I get 4. So those are the next two terms in the sequence. Okay, now here we have to again take this second one and divide it by the first one. So we end up with -15 divided by -3, and we get a +5. And then we do the same thing here. We get a -75, and we divide it by -15, and again we get a +5. So the common ratio here is 5. So we take this next sequence, these next numbers, and we multiply it. We take the -75 and we multiply it by 5, and we get -375. And then we take -375 and we multiply it by 5, and we get -1875. And then we take that -1875 and we multiply it by 5, and we get -9375. Okay, and that's how we take and find the next sequences. So if we talked about a recursive rule with geometric like we did before, we would take that previous term. So remember that f of n minus 1 is a previous term, and we multiply it by whatever that ratio is. So we took the previous term, 36, we multiply it by 1/3 to get 12. We took 12 and multiplied it by 1/3 to get 4. Same thing over here. We took the -75, multiplied it by 5 to get this number, multiplied that by 5 to get this number, multiplied that by 5 to get this number. So we're always multiplying by that previous term. Okay, but if we don't want to work through that recursive rule, if I want to find the 75th term and I don't want to work out the first 74 to find it, we have an explicit rule that we can use just like before. So here is the explicit rule that we have. Okay, so first off, the nth term. Okay, this is the position that we were looking for. So this is the actual term. So the nth term in the sequence. So this is the actual term that we're looking for. That's what this represents. Okay. A sub 1 or f of 1, remember that could be an A either way, is going to be the first number in the sequence. So first number in the sequence. Okay, this R represents the common ratio. Okay, and this final thing right here, the N, is the position in the sequence that you're looking for. Okay, so that right there is the position that you're looking for. That's the common ratio. That's the first number in the sequence. And over here is the nth term. It's the actual term. Okay, That's your answer that you're going to be looking for. There we go. You can see that a little bit better now. All right, so how do we do this? How do we use this? Well, step 1 says to find the common ratio by dividing a term in the geometric sequence by its preceding term like we did before, and then substitute your values and the common ratio into the equation. So just like we did with arithmetic, except we're going to be using that multiplication and division first. So we're assuming that this is a geometric sequence and that it continues. So the height of the bouncing ball on the 9th bounce. Well, the first bounce, it's 3. The second bounce, it's 1.8. And the third bounce, it's 1.08. So we're going to continue on from here. So remember, this is f of 1. So the first term is 3. N is the one that we're looking for. So we're looking for the 9th term. Okay, 9th term. And R, it's going to be found by taking this second term, 1.8, and dividing it by 3. So it's 0.6. So that's what we're the ratio that we're going to be multiplying by. So I'm going to take and plug this in, and I have f of n is equal to first term, which is 3, times the ratio, which is 0.6, raised to the power of n minus 1. So just like that first example of the swing, we took and we subtract out that first term because that's the full height. And so we're going to do 9 minus 1 up here. Okay, so, and I can plug this directly into my calculator. And that's what I'm going to do. I'm going to take 3 and I'm going to multiply it by 0.6, and I'm going to raise that 0.6 to the 9 minus 1. And then I'm going to press enter. And so my answer here comes out to be an approximate answer because it doesn't really stop. So this is f of 9. F of 9 is equal to approximately, so I'm going to use a wavy equal sign, and I'm going to go out through 4 decimal places, 0.050, and then that 3 will round up to a 4, so 0.0504, okay, and that's about how high that ball will be by the 9th bounce, okay. So again, same process for the next question. We have, again, assuming that we have a geometric sequence and it continues, we want to know how many bacteria will be in the culture at the end of 7 hours. So first hour, there are 250. Second hour, 500. Third hour, 1,000. And so we're looking for the 7th hour. So the first term here is this number right here. It's the first number. N is what we're looking for. Okay, remember it's the position that we're looking for. So in this case, it's 7. And the ratio is found by dividing the second number by the first number. So I'm going to take and do 500 divided by 250, and I find that the ratio is 2, which makes sense because I'm multiplying each of these by 2. That's doubling, and that's doubling, and that's doubling. So I'm looking for f of 7. I'm going to plug in my first term, which is 250. I'm going to multiply it by my ratio, which is 2, and I'm going to raise that ratio to the power of 7 minus 1. And then I'm going to plug that straight into my calculator. So I'm going to do 250 times 2 raised to the power of 7 minus 1. And I get 16,000. So at the 7th hour, there are 16,000 bacteria in that culture. Okay? Alright, so we're going to continue on in the next video to talk a little bit more about these geometric sequences.